Hello, everybody. My name is Toby Quinn. I'm a rising junior from East Chapel Hill High School in North Carolina.
My name is Ben. I'm a rising junior from Milton Academy in Massachusetts.
I'm Olivia. I'm a rising senior at Pacific Collegiate School in Santa Cruz.
Hey, I'm Hasnan. I'm from Sacramento,
This,
California.
this is our awesome mentor, Sajad Havori, who's joining us today. And our project is ECO2, the impact of neighborhood crime on educational outcomes.
So as we know that our parents want to send us to the best school possible, right? But academics doesn't. It's not the only factor. We want safety as well. So that's where crime comes in. The two factors. So crime rate also matters when sending your children to school, and the numbers back that up as well. 77% of U.S. public schools report at least one incident of crime, totaling approximately 1.4 million incidents per year. And so the main question we've been trying to answer is, does the increase in crime cause a decrease in enrollment?
So after we gained a better understanding of our research question, we wanted to see what other people had done first. So we read three main articles. The first one being neighborhood violence and school preferences, which showed that neighborhood violence, that parents have incentive to send their kids to schools further away because of local violence. And also community violence and academic achievement, which linked neighborhood crime to educational outcomes such as lower test scores and attendance. And we looked at the impact of community violence by the United Nations, which emphasized global evidence of local crime reducing education.
So from our literature review, we know that there's some type of correlation relationship between neighborhood crime and educational outcome. But we decided to dig deeper and analyze the impact of neighborhood crime on school enrollment specifically for 5 cities in the US. So we did Chicago, Boston, Chapel Hill, San Francisco, and Philadelphia. And as you can see, these cities, some are known to have like a lot of crime, some not that known to have crime. So there's one on the West Coast, one on the East Coast, and one in the Midwest. So it covers a lot of parts of the US, and this makes the data more significant. After collecting the data, we developed a log-log regression model. It links enrollment explicitly to crime near a school and also enrollment to crime in a catchment zone. So you may be wondering, what is like crime near a school? What do you count for that? And what is like crime in a larger catchment zone? Well, crime near a school, we usually define it as a 500-meter radius around the school, and you define the circle around that. You count the crimes in that circle and see if like an increase in those crimes affect enrollment or whether it doesn't affect enrollment. Larger catchment zones are like the neighborhood area. It's not as big as a district. So one catchment zone is like smaller than a district, and there's like a few. And then there would be a few schools in one catchment zone. The main thing that you need to know is that for cities with catchment zones, if you live in one catchment zone, you have to go to school in that same catchment zone. And basically, we just also count the crimes in that catchment zone and see if like the neighborhood also has an impact. Because if, for example, if you go to school in like a better neighborhood, maybe does that count? Or does that matter if it's a worse neighborhood, not just close to school? We also controlled for population under 18 and real income to isolate crime's effect. Because we don't just want correlation, we want causation, right? So if a neighborhood has a lot of population, then naturally the enrollment would increase. But by controlling that, we would just isolate crime. We also got data from 4 different sources: school level data, crime data, catchment data, and census tract data. School level data includes information that school type. School type would be like primary school, middle school, and high school. Location gives us the latitude and longitude of the data of the school, and enrollment gives us like the number of students enrolled in each grade and then the whole school. In crime data, we collected it from local data sources from every city, and that includes a crime description, so a few words of what the crime is, and that helps us filter it down to 4 main categories: total crime, which is just all the crimes combined, violent crime, serious crime, and property crime. These 3 are the main ones we're focusing on because, as you know, total crime can just be like really like petty crimes that are small, that don't really cause safety concerns, but violent crimes such as aggravated assault and homicide, and also property crimes such as burglary and theft, they can also really matter when it comes to safety decisions and decisions regarding public safety. We also have catchment data. So for this Chicago, San Francisco, and Philadelphia that have catchment zones, we've got the data for attendance boundaries, and we map that by converting the CSV into shape files. And lastly, we have census tract data. So we got all the controlled data for population under 18 and household income using the US Census Bureau.
So to gain a better understanding of econometrics and applied economics, because that's what our project is based upon, we read a book called Mostly Harmless Econometrics, recommended by our mentor. It's a widely used book that focuses on, like I said before, applied economics, but also empirical research. So during our meetings, we would discuss key concepts mentioned in the book, and we would also address common causal questions such as, do smaller classes improve learning, and how much does education really raise wages? And we would read and present a chapter every week. So for our data sources, we decided to split our data types into different categories. So for example, for our crime data, we split it into violent, property, serious, other, and total. For school type, we split it into elementary, middle, and high school, with each one of us using varied combinations of all three types of schools. And then for demographics, we grouped it by race and income proxies. So for income, we used income data in general, but we also looked at free and reduced lunch eligibility, because the students with access to this are usually the students under certain income.
So to visualize our data sets, I wanted to create a map. So I used Kepler.geo, which is a GeoJSON viewer. And here's a map of Philadelphia, with pink being the school zone and yellow being the school zone highlighted. And the blue is the 500-meter radius around the school, pink being the school itself, and all the blue dots are the crime located.
So now you know all about our data, but what exactly do we do with this data to actually achieve our results? So the first thing we did is basically want to make a huge data file for each city that combines all the 4 data sets that Ben talked about before. So the first thing we did is we took our CCDC data, or our school data, and then we counted crimes near a school, which is either 200 meters or 500 meters, depending on the size of the city. And we also counted the crimes in the larger area, the catchment zone, or we used a catchment zone radius replacement if the catchment zones were not available for our cities. Then after doing this, we were able to run a fixed effects panel regression using Python. What exactly is a fixed effects panel regression? It's just a normal OLS, or ordinary least squares linear regression, kind of like the last group's linear regression. But with fixed effects panel regression, what you're able to do is you're able to control for 2 very important things. One of those things is entity fixed effects, or school effects. These are things that do not change for a school from year to year. So for example, a school's location, or its longitude and latitude, and also its school type, like is it a public school or a charter school, do not change from year to year. And we also control for time effects. Time effects are essentially things that affect all schools in one given year. So for example, a shock like COVID would affect all schools in a given year, or even like a district-wide policy or economic change could also affect all schools. This is kind of like the brains behind our entire project. It's our specification, or our regression. I know it looks kind of daunting, but essentially what it does is it allows us to basically see how much enrollment changes based on crime rate near a school, and also crime rate in the larger area. So the reason we use logs is because that allows us to find percent relationships. So for example, we can say this percent change caused this percent decrease in enrollment exactly. If we use just exact counts, we would not be able to do that. And the reason we use crime rates is because we control for population. So, areas with more people in it are obviously going to have more crimes. So that's why we use crime rates to actually standardize that. We also control for income here, because income is correlated with the number of crimes in an area. And we also control for the share of different races. This is our primary regression. So this is actually the one we ran for Chicago, which is the first city we tackled. But for the rest of our cities, we pretty much just controlled for the population under 18, or proper age population, and also the income. These last 3 variables are just the entity fixed effects, time effects I talked about, and the last variable is just the error term, or all the confounding variables we did not include inside the regression. So what were our results?
Moving on to Chicago, you can see, not all data is good data, but we accept our results. The finding that we got for Chicago was that there was little to no effect for crime near a school. So you can see for total crime, serious crime, violent crime, and property crime, there are 3 school types, and under these bars, there's a like light blue turquoise bar, and then the orange bar as well. The orange bar represents the enrollment effect on catchment zones, and crime near catchment zones, and then the blue bar is like crime near the school. And you can see that you can't really see the blue bar anywhere, and that just means that there's not really an effect for crime near the school. We also expect going on that for primary schools, especially there's not really a big effect or there's a slightly positive effect. This is because for primary schools, in most of the US in the primary school under the age of 14, you're legally required to attend primary school. And also by attending primary school, while you're at school, your parents do not have to supervise you at home. So there shouldn't be like a decrease in enrollment anyways. So yes, this is Chicago's data.
So when analyzing Chicago, we wanted to see the change in catchment zones throughout the years. And we decided to do this because we wanted to see whether or not the catchment changes were significant enough for us to have to consider them during our analysis. So we mapped boundary changes between years 2000 to 2024. And these two maps represent 4 academic years that show the most significant changes. And these are for elementary catchment zones.
The city I did was Chapel Hill. So essentially the way we tackled this was pretty normal. I just combined the school crime and census data into one large data set and then ran the regression. So for Chapel Hill, because it's pretty small and also the data was more available, I used 200 meters as a definition for nearest school and 2,000 meters or 2 kilometers as a definition or a catchment zone replacement because there was no catchment zone data available. Now these results actually really surprised me. I don't know if y'all have been to Chapel Hill before, but the most interesting thing to do on the weekends is like go to the library. So the fact that there's this much crime was really, really surprising. So as you can see, there's about a 5% decrease in enrollment from property crime, and also a 5% decrease in enrollment from serious crime. Now you might notice that, okay, why is this thing here again? Now you might notice that there's no violent crime. That's because the parameters for violent crime were so small, they did not even show up on the graph. They're like 10 to the negative 17, so I just did not plot them. There's also no effect at all for primary, middle schools for property of serious crime, and also the effect for total crime was pretty small.
Boston has a similar situation as Chapel Hill where there is no catchment zone. So I did a 1 mile catchment replacement instead. The reason I chose 1 mile is because Boston, you might think it's a big city, but it's actually not. And it's a very densely populated city, but it's not that big of a city in terms of area. So I wanted to use a catchment zone replacement that can capture population, but also not the whole area. Also, you can see from the data that the main negative coefficient is from high schools in serious crime and violent crime. There's no effect in total crime because there's just too many of the small crimes as I talked about before. But for violent crime especially, this is very interesting because every 1% increase in violent crime that happens, there's a 0.6% decrease in school enrollment. And if you make that 10%, that becomes 6%, right? So this is a pretty significant data set for violent crime.
So I analyzed San Francisco, which is a city just an hour and a half away from Santa Cruz. Similarly, I defined a 200-meter radius. And for my boundary further away, I was able to get catchment zone data for elementary schools. So I defined a catchment zone boundary. I control for population and control for income. After running my regression, I found that for total property and other crime, there didn't seem to be a really significant correlation. But for serious and uncategorized, there seemed to be, especially for the 200-meter radius, there seemed to be a very negative correlation compared to the catchment boundary. And for violent, surprisingly, there was a positive correlation.
So I did Philadelphia. I also had a control for population under 18, and I luckily had school zones. I also had 500-meter radius around each school. And we saw that the impact in the zone, the orange bars here, was way weaker than the impact of 500 meters around each school, as the impact was way stronger.
So there's a few things we want to do with in the future with this project. One of those things is incorporating instrumental variables or IV into our project. What this will allow us to do is essentially reduce all confounding variables by introducing a new third unrelated independent variable. And we're thinking about using police stations as this. We also want to just add more control variables listed on the slideshow. The third step we're going to take is to define the near radius of buffers based on school size. So smaller schools would have a smaller radius and larger schools would have a larger radius. And then our final step was just to expand analysis to more cities so we can make larger generalizations about regions of the US or even the US as a whole.
So through the 7-week program, we got to just experience the whole research cycle, although we're still trying to refine our final data. We looked through regressions, how to construct instrumental variables, and also it was really interesting getting to clean, merge, and analyze large spatial data sets with 4.7 million crime observations. And just get even in the end, achieving the net results was really fun. The bibliography. And yeah, thank you guys for coming. Hopefully you guys enjoyed this and learned a little bit as much as we enjoyed our 7 weeks here. And final thank you to Sajad. Such a great mentor. I really appreciate working with you. Thank you.